Polynomial functions have interesting characteristics. The degree of the polynomial not only tells us the information about the end behavior of the function, it also tells us the number of roots. So lately we've been talking a lot about polynomial functions. So yesterday, when we were graphing in class, we were taking and multiplying linear factors to create the polynomial functions. And so we were able to look at the roots and go that way. So this number of roots bit, we started to talk about how many roots a cubic will have. So we know a cubic has 3 roots, and a fourth degree polynomial has 4 roots, and a quadratic function has 2 roots. So in Math 2, we talked about the fundamental theorem of algebra, which states that an nth degree polynomial function has n roots. So that's what we're talking about here, is that, or solutions. So keep that in mind. That's how we got back to, in Math 2, the complex numbers. That's how we introduced them. So we're talking about these roots, and with roots, that's where it crosses the x-axis. So x-intercepts, roots, zeros, and solutions are what we're talking about here. So these are all those same words. So just keep that in mind. We're also talking about x-intercepts, solutions, and the other word, which is zeros, that all mean the same thing, where it crosses the x-axis. Since we're moving into polynomials with degrees greater than 2, we need to keep in mind the fundamental theorem of algebra as we go through this. So we're going to be working on sketching some more graphs today. So we have these 6 graphs below on our notes. We have questions 1 through 6, and you're supposed to make a conjecture about the shape of each function and sketch the graph below. For example, as I look at number 1, I think that will be a parabola because there's 2 roots and it's going to be squared, so I think I'm going to graph a parabola. So let's go ahead and try it. We're going to have x plus 1, that gives me a root of -1. X minus 2 gives me a root of +2. I know since there's only 2 roots and I think it's a parabola, that means my vertex is going to be in between at 0.5. If I plug in 0.5, I get 1.5, -1.5. I multiply those and I get -2.25. And so that's where I think my end of my vertex is. My y-intercept, if I plug in 0, I'm going to get -2 using symmetry, and then I have this pretty graph. Now, that's what it said. So first of all, my conjecture was that it would be a parabola, because it said a conjecture about the shape. And then I do that. So I'm going to do that for each problem. I'm going to make a conjecture. I'm going to do my best to sketch a graph. And so that's what it says. Then question 7 at the bottom of the page says, once you've made a conjecture about the graphs, confirm your results using technology. So that means either Desmos or your graphing calculator to see if your conjectures are confirmed. But after you've made your conjecture, after you sketched your graph, then we're going to go make sure we're right. So right now we're going to go jump over to Desmos and see if we are right. And so here's Desmos right now, and I had, my problem was x minus 1 plus 1. Was it plus 1? Let's see, we have okay, a little jumbled up right there at the end of that. So let's go ahead and look at our problem, which was x plus 1 and the times x minus 1. So there it is. If we look at our graph, let me put it so you can see all of it on the screen. We've got our 2 intercepts here at 0, 2, 0 and -1, 0. Our y-intercept is 0, -2, and our vertex at 0.5, -2.5. So we made perfect conjecture. Everything is great. So that's the idea. Now I'm going to do a few more examples as we go through this, and then I'm going to expect you to do the last few by yourself. So let me jump back to the pit problems, and let's look at number 2. So number 2 is a little different. What do we think we have here? So if we look at this picture, we've got x times x minus x plus 1 quantity squared, which means we have 3 x's because of this squared, and that means it's cubic. So cubic shape means that we're either going to have something like this or something like this. That's what we've experienced so far. We've got it opening up, so we're not worried about any of that stuff. So our end behaviors are basic. So we're going to go ahead and start with our zeros. One of our zeros is at 0 because we've got x in front. and the other one's at -1. But then I have 2 of them at -1, and that doesn't really make a lot of sense. So what does that mean? Now, my conjecture is it's doing something like this, and I know that the ends, one's going up and one's going down because of the end behavior. What's it doing in between? That's a hard question. So is it somehow looping and turning around? Like, but it can't really cross over again because I only have the 2 answers. What's happening? So this is where my conjectures kind of run out. So I'm gonna guess that it does this, where it goes through and then goes down. But that doesn't really make a lot of sense to me. So I'm gonna go ahead and jump over to Desmos again and see what I can see. So because my estimate seems a little funky. So what I'm going to do first is put the x in front of this parenthesis of x plus 1 times x, and then I'm going to square it. And it's really weird right here. Let me turn these off. It's really weird here in the middle. So I'm going to zoom way in, and between 1 and -1, it kind of bounces off at -1 and turns around almost right away to come back up at 0. So I need to adjust my graph because it was wrong. So I'm going to go back to my graph and adjust this part in between. And since it's so close together, what I'm going to do is actually not count by 1. So I'm going to have this be 0, and I'm going to have this be 1. So every 3 is going to be 1. So this is -1, that's -2, this is +1, and +2. Since I'm not counting by 1s, I'm going to do that. So I've got my dot here. I know this end's going down, that end's going up. And what I just discovered is it comes up, bounces off, and turns around in between these. And so it's doing something like that. And this looks a lot sharper than I want it to. So I'm going to kind of try to clean that up a little bit right here and make it look less sharp. I want it to bounce and turn. Does that make sense? So that's what so based on my picture. So with this squared thing, it bounced. So I want to keep that in mind. So now I'm going to try number 3, and number 3 is going to be the last example I do for you. And I've got these 2 roots. One of them is again at -1. And I think I'm going to count by, I'm going to make these, I'm going to go with 2s this time. So these are all going to be 2s, and I'm not going to put the numbers on, but they'll each represent 2 squares and see if that makes any difference. So I've got -1 is one of my answers, and +2 is my other answer, but they're both these squares. And so what is this? This is to the 4th degree, which means both the ends are going up. So the only time I've ever done a 4th degree before, it was kind of looked like a parabola. It's not, but it kind of looks like one. So I'm going to do that. So I've got the ends are going up. Now I can go underneath, but based on that weird bouncing thing, maybe it bounces again. I don't know. So I think I'm going to have it bounce just for fun there, and then come back here and bounce because maybe it bounces. I have no idea. I'm just to give myself another point. I'm going to go ahead and plug in 0. I'll get 1 times -2. And so that will give me -2. So I think my guess is wrong. But let's go look at Desmos and see what it says. So going back to Desmos over here, I've got that already squared. And so see how it bounces right there when it's squared, like with a parabola? That's kind of cool. And so I'll put x plus 2 over here, squared. And I need to zoom out a little bit. Oh, that's wrong. That should say 2x plus 1. So, and that should be squared. And look, see, it does bounce. And what did I do wrong? I typed that wrong. This should be a -2. See, it is bouncing. And I plugged in 0 wrong, apparently. Yeah, I plugged in 0 wrong because I forgot to square. That's what I forgot. So anyway, 0 is +4. And I was right. It's this weird, almost W shape. That's strange, but that's what it's doing. So by using Desmos to confirm after making a guess, and my guess on the second problem, you'll notice was very much based on this bouncing thing that occurred on the previous one. So I thought I'd probably bounce in between. Now I'm going to clean this up a little bit based on my graph that I just made. The y-intercept was +4, so it went up and came down, and so that's going to be my guess graph. So there I am, and that's what I want you to do with the last one. So remember, you're going to try to graph them first, and then use Desmos to confirm them. Your goal by the end of class is to have this first page done and get started on the go part of the Ready, Set, Go homework. And I might actually, go part of the Ready, Set, Go homework, and we'll talk about it more when I see you again. Have a good day.